that is K permeability. The dimension is square meter. So the Darcy is the ability of filtration. So Darcy number is 1. 1 is standard. If it is less than 1, then the rate gonna be a little bit slower. If more than 1, then the rate gonna be a little bit higher. But industry, the rate is important. It's related to money. The rate is important. So the Darcy K value is quite important. When you look at the Darcy's equation, the other side of the equation, that is quite practical. That's what you need to understand. Mu is there, alpha is there, and epsilon is there, rho is there, and Q. The Q, you already know, flow rate, mass flow rate, Q. Higher filtration rate per unit area Q, and K resistance alpha. This is normally, if you have a lot of the experiment, you can get some and the value using this. The book you have, the important thing is the Professor Iritani, he did a lot of experiment. Probably he had a lot of graduate students. So experimental data is really important to understand. So that's why I chose that book. When you look at it, a lot of experiment, how to interpret experimental data. He used a little bit different than the most of other scholars. Also, he didn't use K at all. He used his own resistance kind of equation. But it's really similar to Darcy's equation, except for permeability K. He used the resistance, the function. But important thing is he did so many experimental data. He tried to come up with some relationship between the data point. So you don't have to read all those experimental section, but somehow I want you to understand the trend. The trend itself is quite important as well. I already indicate in the book anyway. There was written in Japanese and then translate Korean. Then I made English version. So the mu, alpha, epsilon, rho, Q, that is quite important for liquid filtration. The other important thing is the K value, the permeability. See, in fact, the permeability is not the simple value. This is actually so-called tensorial value. The vector is one dimensional. Tensor is three-dimensional quantity. So K is three-dimensional quantity. So the equation itself is really complicated. The momentum balance equation along with the permeability into it. Yeah, Darcy's equation is a little bit different form. The Professor Iritani, he used similar to this one, except for the K. He used a little bit different the parameter there, but his formula is really close to it. Why this is important? The Q and pressure, mu is viscosity, and then L is length, and then Rm is resistance of media itself. See, I hope you could do some experiment. I don't know when when we're gonna have it. Do you know?
Tomorrow.
Huh? Tomorrow? Are you sure tomorrow?
Yes, sir.
No, it's not tomorrow. Huh?
Day 3.
Huh?
Day 3. After tomorrow.
Day
Day after tomorrow.
after tomorrow? See, I brought some filtration devices from. I actually mailed it to him, but somehow he had a trouble to get it from the custom and immigration. But anyway, we do have it. So I hope you can do some experiment. At least you got some idea how to do. In fact, I sent some drawings how we can do them slowly filter. But since the textile department, they didn't have any previous experiment. So it didn't work. And that's why I brought. But anyway, you can do some experiment. Oh,
Tomorrow's tutorial class we will have experiment.
what?
Tomorrow in tutorial class you can do experiment by compressing this session.
No. You said it's not tomorrow. The day after tomorrow.
That is
Huh?
full schedule practical is day after tomorrow, but they will be done by Mr. Ekechal.
We can do it the day after tomorrow.
You can do it tomorrow
Yeah.
in tutorial also.
Well, we're gonna work together tonight until midnight. I don't know.
You can take 1 hour, you will take 1 hour.
Huh?
2 hours to learn. You will take 1 hour, you can take 1 hour. Or tomorrow also if possible.
In tutorial.
Tomorrow in tutorial class,
Uh-huh.
if possible, you can also make it 1 hour tutorial and then you can put experiment.
Experiment?
Yeah.
The setup is not ready.
Setup will be ready by tomorrow.
Okay. Yeah, we can do that. See here, I really prefer to do the experiment. So you have to do the experiment, then you can understand principle a lot easier. So, experiment is quite important one. That's why I brought something, so that you can actually hands-on experiment. You have to have hands-on experiment. If you do the course like this at US somewhere, in US somewhere, then you can actually look at my lab as well. But it's not. Anyway, why this is important? This one is resistance of media. this one is resistance of flow itself, liquid itself, and then pressure. So important thing is the Q. Q is proportional to what? Pressure, right? I don't know whether you notice or not. K value, if K value is big, then Q gonna be small. So if K value is low, then Q gonna be really high. That's Q is the money. So the rate is. That's why this one is kind of media related. Then you have to use this equation. This one is more like resistance. So the rate related equation.
Sir,
Okay, here. Huh?
I have a question regarding the assumption of this statement. What are the assumptions?
Assumption.
Assumption, because this law also has some assumption.
Uh-huh.
Because you should be the Newtonian, non-Newtonian. So what are those assumptions?
Okay, here. Assumption. That's quite tough question. The first of all, you have to assume that the media is the bunch of the capital. I don't want to say it. That's a big assumption there. Yes. Correct. I believe he knows some.
The point here is that if it is a compressible cake, it will behave like different way.
Of course.
Depends on the compressibility of the cake also.
Yes. The compressibility and that one is really depending on the particle shape. The particle shape. Yeah. Yes, correct. That's the basic. I don't want to say it's overall, but you are correct. Here, the permeability value right there. So if it is smaller and then large, then it's the easy and very difficult something like that. Real world settling velocity. Here, first one is, what is that? All the assumption we have is all the sphere, but that is not like all the sphere particles. The shape is so different. So in present of a large number of other particles and possible to form aggregate, normally the particle you have is not a single particle. It's agglomerated. Yeah? That's why the theory is a lot different. So you have to separate everything out. So the real settling rate is quite different. But you have to know the shape and the rate of the agglomerate. So the Stokes equation, we're going to go over the Stokes equation. Transmembrane is more like the cross-flow membrane. In the TMP, transmembrane pressure, you have to know P incoming and P outlet. Then you can calculate the P, and then P permeate 1, P permeate 2. So the coming out the permeate is different. Huh? So somehow you have to know permeate. What is permeate? It's solution. solution, the density gonna be different. This field separation mechanism, air bubbling, we already discussed about that one. This is related to compressibility. So if the K is incompressible, which is K is constant, then it's straight. If K is decreasing with the pressure, it's compressibility related. If it's highly compressible, then you have curve like that. So somehow we want to have some sort of experiment. But I don't know whether you notice or not. Down here, AFS, which is American Filtration Separation Society. This is the material they are using right now, not a year ago. This. See, I was the chairman of the American Filtration Separation Society 10 years ago. The board member for a long time. Also, I was instructor for the teaching the courses as well. Not now, though, because I like to make the here Jarenda. Maybe 2 years later, something like that, 3 years. The centrifugal cake filtration. See here, if you have the centrifugal, then you have to know omega, angular velocity. The angular velocity. Also, you have to know the length. The R value is quite important one. The other important one is the same as the previous one. Media resistance. The media resistance is there. So this is not that complicated equation, but as long as when you look at the system itself, this one is probably centrifugal cake filtration. They use a lot on the system. And Stokes settling velocity. The Stokes settling velocity, the important thing is the settling velocity is equal to gravity acceleration. Right here, G value. G value is important. And also particle diameter. Certainly the viscosity is quite important. In fact, the equation itself is quite simple, simpler than Darcy's equation. Yeah, centrifugal settling. So R value is important. This is not the W, this is supposed to be omega. Also FT is the MR square over G. This one is really simple principle of the centrifugal settling. G force. See here, we cover some of the principle of the filtration. Without having experiment, it's not easy to understand the principle itself. So, sometime later, before he got the PhD, he may be able to use a lot of his own lab. You know, just get first of all, constant pressure filtration. That's the first one we need to do. Second one, the constant rate filtration. Rate filtration is quite important one. But if you have some setup, then you can actually do the experiment rather than looking at the theory itself. F G force, G force there, and then R omega square. You already know this one. Gravity settling and flotation, centrifugal, magnetic analysis. We already covered that one. And straining. What is straining? It's simple. It's sieving. Because not many, the cost involved, that's why there are more straining filter in number one than any other filtration, liquid filtration equipment. It's not like the air filtration. Air filtration, the smaller the particle, you can catch a lot better, and that's the air filtration. But straining wise, the other way. You can catch the larger particle and not the small particle. Straining equipment, screen. Probably you only see in them screen the straining equipment as the water filtration is the first step. It has to go through the wire mesh. Goes through wire mesh first. That's a, same thing. You will see some wire mesh there. That's straining. They're good for separating larger 100 micrometer particles. Yeah, water, erase water. First step, you can see right here. All of them is wire mesh there. See, I'm not really used to the 2-hour continuous lecture. See, my voice is getting. Also, when I was teaching at the university, I don't have the lecture 3 hours a day. Something like that. Today is a little bit different. And manual cleaning strainer. Probably he already covered some of them already. The self-cleaning strainer. That is backwashing. I don't know whether he covered the back filter. Huh? Yeah, you already did it, right? Yeah. You already covered that one. Cartridge that one. Huh? Yes, yeah. And yeah, cartridge filter as well. Cartridge filter. You have the video making something like this. So when I look at it, I actually laughed at it because we used to have that type of the video. It's every product we used to have that video. So I didn't include any video at all. because I don't know whether it's allowed or not. The industrial cartridge filter and back filter, I think he already covered that one. Cartridge filter. This one already. Here, I can tell you one thing. The design of the pleated cartridge filter. Now they have a lot of different shapes of cartridge filter. The pleating. Yeah. It's not very regular pleating like this. It has a lot of variation. One small, the other one big, something like that. Yeah. Because liquid filtration, the pressure is higher. That's why you need to have special arrangement of pleat filter. Here, I show you some difference. Uh, how to design and string wound, plated, particle size, and flotation efficiency, filtration efficiencies. Then you can, well, you have to have a lot of the experimental data so that you can design appropriately. The beta rating is quite important as well. Absolute rating and nominal rating. I don't know, some of them probably familiar with this one. Absolute rating and nominal rating. When you read this one, probably you'll understand a little bit better. Do you know beta ratio? This is quite important for the liquid filtration, especially the oil filtration. Beta rating. Number of particles in feed, number of particles in filtrate. The equipment, you can buy it, but it's not cheap. It's quite expensive. I don't know who actually made the name of beta ratio. So beta ratio is common technology in liquid filtration. Yeah, here the beta ratio is 2, 5, 10, 100, and filtration efficiency starting 99 to 99.9. Then the beta ratio is 10,000. Then it is 99.9. Cartridge, a back filter design. First, determine the reasonable removal efficiency and know the solid concentration. The cartridge back filter I used for low solid concentration, roughly 50 milligram per liter. I don't know whether I can continue. I'm kind of. Oh. The material that I'm covering right now is currently the American Filtration Separation Society, the short course material, exactly the same. Currently using this one. Back filter design. So all of them relate to the design, how you design the back filter. Previous one is the same thing. Cartridge filter, cartridge back filter. So this one has some sort of the design criteria. The 5 micron rated cartridge is likely tighter than 20 micrometer rated. So you have to consider overall economics. I hope you can read and through it. I'm going to go through it. K filter. The K filter, probably you already knew what the K filter is, right? Yeah. So also we covered the principle, the Darcy equation as well. The K filter, there are several steps you have to go through. Discharge, and then you have to clean the discharge solid material, how to clean it, and then you have to dry it too. So it's really what you need. What you need is solid part or liquid part. So more likely pharmaceutical, they do use both. The K filter, gravity, vacuum, you already covered that. Pressure, same thing, compression, and centrifuge. Gravity, vacuum, pressure, we already covered that one. Compression filter, filtering centrifuge. Then what I'd like to show you is the American Filtration and Separation Society. They do have the show course 2 times a year. Most of the attendees, they are from industry, not academia. But when I look at, I ask him what's the background of attendees. Some of them from industry, most of them from academia. So from academia, the design is quite important. So if you want to design something, then you have to have experiment. So you have to have experimental setup so that you can design appropriately. So if like this course, I'm actually emphasizing to make some filter experimental setup. So if you have the constant rate is not easy. That is most the difficult experiment. But at least constant pressure experiment, that's quite easy one. So I'm going to ask Ajay to do some test beforehand, before the class. Yeah, calculate the gravity, settling the material. I think vacuum filter. See, yeah, this one has actual number in it. The number, the K value, as well as. See, this is the based on the experiment they do. Probably the data came from Dow Chemical. Dow, they use a lot of experiments. Vacuum filter. But what I like to say is you're getting the information, most updated information. All of them are AFS down there. This is really updated slide. So, like I told you, I never had the 2-hour continuous lectures before. Uh, so I'm kind of a little bit tired. I don't know why, but somehow I'm
You can
kind
have 5 minutes left.
of. Oh no, no, it's okay. It's okay. I can stand, but my voice is getting lower. That's the trouble. But I can tell you one thing: the material you have is not old one. It's really recent one. The material you have right now. The They are not.
Time you take?
Huh?
How much time will take now?
5 minutes. That's what you
5
said.
minutes.
Yes. So I can tell you one thing. Go over the material you have. That's really recent material. Yeah? You cannot get it from somewhere else. Yeah? Only you can get it from me. But don't tell who gave you the AFS. It's okay. I was chairman of the AFS. I don't think anyone could sue me. I don't know. So in America, suing is the most popular things. So anyone could sue anyone. But the important thing is the information itself. You have most current information, even though I didn't go through everything in detail. So uh, I think I have a lot more. the the principle we already covered. He and myself. He already showed some of the slides there too. But this one, they has real data in 1 to 3 minutes for the revolution, something like that. Same thing. Same thing. He showed some of the disk filter. Yes. Huh?
This one also I am showing.
Yes, yes, I know that. This is filtration setup. Jose, this is called Erlenmeyer flask. This is what you need. You need to go to the chemistry department, then you can get it exactly like this. So you have to get the Erlenmeyer, and then balance. Balance is important one. Balance, yeah, balance. I'm gonna. I gave you some the written. This is the experimental setup. Cake filter design. Baking filter design. So the water and suspended with the CaC or OH2, and then 8% weight percent. Well, go through it because we don't have the experimental setup. I don't think it is necessary to talk about it. Cake filter design, area, and then filtrate unit for that. I don't know. I might have a lot of the data along with this one, but I hope you can read through it, and then if you have any questions, then I'll give you my email address. Email address is kchoi, and the number 228 at gmail.com. My name is KJ. You don't have to write prop on the doctor. KJ is good enough. Yeah, I don't know whether you noticed. I changed it. KJ. So I'm really quick to responsive. Eh? So, but important thing is you have to write where you met me. In Jarenda, that's good enough. Then I'll give you some in detail. Especially the issue you have in the workplace. That's what I like to know. And then problem you have. Because I have a lot more experience, yeah, experience than anyone else. Yeah. So, any special question? You have my email address. Send it to me. And somehow I'll guide you right place. Huh? Okay, that's it.
All over. Okay, I am having one or two points. Tomorrow at 9:30. Sir, please take a seat.